triangle ABC, and this is not an unusual question. This is something that you should already know. They're asking you to classify it by sides. So somebody yell out what kind of triangle is if you classified it by sides.
A normal triangle. A normal triangle.
So scalene. Scalene means it has all different sides. So the side lengths are all different. You really don't know what the angles of this triangle are. There is a way to figure out the angles of the triangle. You haven't learned it at this point. And they look acute, but you don't really know that those are acute angles for sure. They probably are acute angles, but you would know it's scalene. So it's a scalene triangle. So all the sides are different. Now, if the sides are all different, the angles are all different. That's a theorem that you learn. And so it says, which angle is the largest angle? And that's not a question you've been asked before. You know, which angle is the largest? And it's not asking you which one appears to be largest. It would be based on the numbers, not based on the way it looks. So, which based on those numbers, which angle do you think is the biggest one here? Grant, what do you think?
C.
C, because it's across from the 27. And do you guys think A is the smallest?
Yeah.
Okay. And I want to show you something here that I think will help people understand this. Let's say I had a triangle where all the sides were 20. Okay. And then I took that side that's 20 and made it bigger. If you make that 20 bigger, 24, let's say, does that angle get bigger or smaller? So as you make a side bigger, the angle gets bigger. The bigger you make the side, the bigger that angle becomes. And likewise, if you made that side smaller, that angle becomes smaller. So we're going to write the rule down in a second, but you're right, it is angle C. And the smallest angle, what do you think? A. And the theorem is this. In a triangle, the largest angle is opposite the largest side. Opposite means it's not touching it, right? 27 is the biggest side for sure. And opposite is the angle that's not touching the 27. A and B touch the 27. They're not opposite. C is opposite. And then this is the smallest side. Across from that is A. That's the smallest angle. And again, don't judge it by the way they look. Judge it by this rule. Sometimes people are asked questions like list the angles in order from least to greatest, and they'll write down 83, 85, 87, which is just putting numbers in order, which, you know, it's nice that you can put numbers in order, but that's something that they ask second graders to do. So they're not asking you to put the numbers in order from least to greatest. They're also not asking you to put the sides in order from least to greatest. It says angles. So if you say, you know, the least is WY. WY is a side. So WY is the smallest side, and we all know that's the smallest side, but don't write the smallest side. So you guys yell it out. What's angle is the smallest? Angle Z. So this is the smallest side. Across from that is the smallest angle. I draw these intentionally so it's not obvious which one is the smallest. Don't get out a protractor and measure the angles because things are not drawn to scale. You cannot assume relative size. And W looks smaller than Z, but Z is the smallest according to these side lengths. What's next? Y and then W. This is the largest side. W would have to be the largest angle. Things in geometry do not need to be drawn to scale, exactly where the largest angle looks like the largest side and the smallest side looks like the smallest side. Whatever they're labeled, that's what they are. If those are the true measurements of that triangle, no matter how well it's drawn, those are the order of the angles. Okay, so on number 4, it says, list the sides in order from least to greatest. So it's the opposite. What do I need to do first on this problem? Find the missing angle. Okay, sometimes people don't do that. So you have to find the missing angle. We have to use this rule that the three angles add up to 180, and I get 31 degrees. And again, some people will put the angles in order. It says sides. I wouldn't ask you to put the angles in order from least to greatest, because that, again, is not a high school level skill of putting three numbers in order. It says the sides. So which is the largest side here? Yell it out. XZ. And when you write that, you're going to write it with that segment symbol. You know, it's okay to say XZ, of course. We're talking about segment XZ, and so write that line there. Would it be okay to say ZX? Yeah, same thing. Okay, yell it out. What comes next? I was going to write WZ, but ZW is the same thing. So this is the next smallest angle. So across from that is the next smallest side. This is definitely the largest angle. Did I do this wrong? No. Why is somebody telling me? Okay. Let's start this again. All right. So the least is WX. And then XZ is the largest. I was doing it from greatest to smallest, so I was messing it up. Okay, I think I have it right now, right? The smallest, and then the largest, and then obviously the one in the middle. Okay, yeah, I had a mistake there. Oops, I keep erasing that 31. I want to leave 31. Largest side across the largest angle, smallest side across the smallest angle. We're moving on to a different theorem. Okay, there's this theorem called the exterior angle theorem. And the exterior angle theorem is one where you a lot of times can get the answer more than one way, but there are some rare times when you would want to use the exterior angle theorem because it is the easiest way. And for this first problem, it's demonstrating that the exterior angle theorem works. And like I said, this problem can be done two different ways. And then we'll do some that can only be done, or at least easily done this new exterior angle theorem way. So first of all, what is an exterior angle? It says an exterior angle of a triangle is found by extending one of the sides. So this extension of this side creates this exterior angle. So this is where the exterior angle is. Okay, it says BCA, that's an exterior angle. If you have a triangle, extending the sides like this would create exterior angles. Some people might ask, like, if you extended them like this, wouldn't you have more exterior angles? And so all of these are exterior angles. I'll do them in different colors. All of these would be called exterior angles. The two purple ones are equal. The two red ones are equal, and the two green ones are equal. So whether you drew the exterior angle on one side or the other wouldn't matter. Okay? So usually you talk about just one or the other, not both. But when you see that shape, those are all the exterior angles. The purple ones are equal, the red ones are equal, the green ones are equal. And I'm going to erase this now. So this is an exterior angle. If you were to extend like this exterior angle would be the same. But they're only asking you this one exterior angle, BCA. Okay. Now, there's two ways to find BCA. So we'll find it the old way, and then we'll talk about this new way, and I would understand both. So what I'm going to do first, I'm going to find this angle right here. Do you agree that angle is easy to find? The one in the triangle? So I do 180 minus 43 minus 57, and I get 80. Okay. Do you think you know what BCA is?
Yeah.
What is it?
100.
100. Okay. So you knew that because you have a straight line right here, and these two angles. What do you call that those kind of angles? Linear pair, which are supplementary. Yeah. So you could say they add 180. You could say they're a linear pair. You could say they're supplementary. The theorem is that every linear pair is supplementary. So they add to 180. So that's 100 degrees. So measure of angle BCA equals 100 degrees. Now I did not do this exterior angle theorem I haven't explained the exterior angle theorem yet. I did this using two other theorems. I used the fact that the angles add up to 180, and I used that linear pair adds up to 180. Now, see if this makes sense to you. These two things add up to 180. Okay, always. These three things add up to 180. Always. They both share this 80. You following me so far? Okay, so let me say this again. This 80 is in common for both. These two things add up to 180. They have that 80 as one of them. These three things add up to 180. They have 80 as one of them. So these two things have to add up to the same as this number. What's 43 plus 57? 100. Okay, now let's label these things. This is called an exterior angle. All of the angles in the triangle are called interior angles. These two, in relation to that exterior angle, are called the remote. Remote means that they're far away. Interior angles. They're the ones not touching the exterior angle. So this is the theorem. The measure of the exterior angle of a triangle is equal to the sum of the measure of the remote interior angles. So if you add those two angles that I have highlighted, the remote interior angles, you'll get that exterior angle. We'll use that theorem in different ways here. And you don't need the theorem for 2. You really don't need the theorem for 3, but it makes 3 a lot easier. And then that's it. Okay. So we'll talk about we'll talk about everything on this problem. It says triangle BEP is isosceles with base BP. If it says isosceles with base BP, that means that that's the one that's not the congruent one. Sometimes they say with the vertex E, and that means that would be across from the base. So the base of the isosceles triangle is the one that's not the congruent one. So if it's worded like that, the other two are equal. So those two are equal. Okay. Now I'm supposed to find this angle here, EPN. Now I can't find it right now. I would need to do something else. Somebody want to tell me what they would do here for the next step? How could I progress on this problem? I wouldn't use the exterior angle theorem. Isaiah?
Just like cut it down the middle, and then you know that the angle being equal here.
And this is true for every isosceles triangle. Every isosceles triangle is symmetrical. So when he said cut it down the middle, it means there's a line of symmetry, and those are equal. Now, whether you draw that line or not is up to you. Okay? I like you to know there's a line, but I don't think you literally need to draw a line. I think you could do without drawing the line, just know those are equal. But if you like to draw the line, I think that's fine. I'd rather you draw the line and know that it's there than to have no idea that those angles are equal. So I did 180 minus 38, that gives me 142. I know those are equal, so I divide by 2 and get 71. 71 degrees, 71 degrees. Now this one I don't really need the exterior angle theorem. Because some people say, well, you know these two add up to 180, so just figure it out that way. The exterior angle says that if you add these two, you get this one. And it should make sense, because if 3 things add up to 180, and they both have a 71 in them, and 2 things add up to 180, they both have a 71 in them, they should be the same. So I'm going to do 38 plus 71, and I get 109. And then I could double check it by saying these two should up to 180, and they do. So there's 2 ways to find that one. That involved some things from yesterday. So you need to know about isosceles triangles. You need to know that the opposite sides are, have opposite angles. If opposite sides are, I'm sorry, if there's 2 equal sides, there's 2 equal angles. And that goes along with that theorem that we learned You know, we learned that theorem that said that the bigger sides across the bigger angle, the smaller sides across the smaller angle. So if these sides are equal, and the bigger sides across the bigger angle, the smaller sides across the smallest angle, then these cannot be bigger or smaller than each other. Equal sides would give you equal angles. Okay, I can't have these angles not be equal because then those sides wouldn't be equal. So though that theorem, that new theorem kind of goes along with that old theorem. And you could just say if the biggest sides cross the biggest angle, small sides across the smallest angle, then if the sides are equal, the angles have to be equal. And so, anyways, let's do this last problem. A lot of letters going on here, so you got to put the things in the right spot. When I go YWZ traces out this angle up here. So I'm going to draw a little arrow to this one and say this angle is 4x plus 17. The next one, Z is in the middle, so that's where that angle is. That's 5x minus 20. That's here. We have no idea if those are equal or not. We have no idea if they're acute or obtuse. We don't know anything about those angles except for what it says. Then it says x, y, w. If you're not paying attention, you'd be like, oh, angle y right here. But that's not where it is. This angle's out here. X, y, w is this angle. This is going to be an obtuse angle. At least it looks obtuse. You don't even know that for a fact that it's obtuse, but it looks obtuse. And it's definitely an exterior angle, that you know for sure. Like there's no doubt that that's exterior. If the drawing was like this, you know, this, not my best triangle, but this could be acute. So we don't even know that it's obtuse, but we know it's exterior for sure. Okay. The problem here is, like, I do know these three angles add up to 180, but, you know, I have nothing written on this one. So I can't use the fact that they add up to 180 with these values anyways. There is a way to do it, but it would involve writing this in terms of this. I'd write 180 minus x minus 10, and that would be what I'd write here. And then I'd add up those to 180. That would be the tougher way. The easier way is to do the exterior angle theorem, and that's what we're going to do. The exterior angle theorem, in case you didn't catch it the first time, says that the exterior angle, which is this one, is equal to the sum of the two angles that are inside the triangle that don't touch it. The name of those is remote interior angles. So those two remote interior angles, those that don't touch the exterior angle, add up to the exterior angle. So the 4x plus 17 plus the 5x minus 20 equals the 8x plus 10. And this is the only way you would use this theorem, really. In other situations, I probably wouldn't bother with this theorem. Like, I wouldn't probably use the theorem when I did 1. It makes 1 a little bit faster, but I don't really need to use that theorem. 2, I didn't really need the theorem. This is a situation where these are all variables where I would use this theorem. Okay, this is a good review of solving, so we'll go through this slowly. You guys tell me. I have 4x, 5x, and 8x. Can I add them all together? No. The equal signs over here. Could I go like this, minus 4x if I wanted to? I could do that, but that's not the order that I want you to do this. Could I go minus 4x like this? Definitely not. Okay, those are on the same side of the equal sign. Whatever you do on one side, you do the same thing on the other. What about adding the 4x and the 5x? Okay, if you have trouble with solving, you should write down the steps that I'm saying out loud. Okay, I've written them down for you. I've said them a million times. You simplify both sides. That's step 1. So I'm simplifying this side. I'm not doing anything with the other side. So I add these up. I get 9x. Should I add these together or no? Yeah, that's still simplifying. That side's simplifying. Now, is there anything I can simplify on the other side? No. Sometimes you can't simplify it, the thing. So I simplified both sides. That's step 1. Simplify both sides. Then step 2 is get the variable on one side. So either do minus 9x to both sides or minus 8x. Which one do you like better, minus 9x or minus 8x? minus x. So step 2, get the variable on one side. Step 1, simplify both sides. Step 2, get the variable on one side. Is it better to put a 1x or just write x? It doesn't matter, but you don't really need that 1 there. So I would just write x. You got one more step to do. You can do the last step on your own. This came for you.
Bro, what?
Okay, so now I'm going to get x alone. And I get x equals 13. And I got x equals 13. The last step is to isolate the variable. So it's simplify both sides, get the variable on one side, isolate the variable, which sometimes takes 2 steps. Some people put a 1 here, and they go like this, they like 1 there, and they go up and divide by 1. You know, you did nothing, okay? So if you divide by 1, it's not going to ruin the problem, it's just that it's unnecessary. Okay, am I done with this problem, x equals 13? Okay, you got to make sure you don't accidentally stop just because you found x. It says to find w, y, z. Now how am I supposed to do that? I can't plug that into this one. Because I don't know that. I don't have something in there. Go ahead, Ish.
Can you plug into back here, 8x plus 10?
Plug it into that one? Okay. And 8 times 13 plus 10, 114. Is there any use to plug it into these?
No.
I like to check it. So the only reason to do this is to check it. And I get 69 degrees and 45 degrees. Now let's do 69 plus 45, and that should equal what? 114. That's the exterior angle theorem. We said that that should be true. Now, you're right, I'm going to do 180 minus 114 because these two have to 180. I could also do the 3 angles of a triangle adding up to 180. And I do 180 minus 114, and I get 66. If you did 180 minus these two, you would get 66 again because those two have to 114. And hopefully you could see why that's the same. So the measure of WYZ equals 66 degrees. So a lot happening there. That's the exterior angle theorem. And you have to make some sense out of that by practicing it. So do the homework. You should do homework 1 and 2 by tomorrow so that you're up to date on the homework. And that's it for the notes.